All right, so I'm going to be talking mainly about asset lifecycle information management. And then there's a couple of cool things that that's outside the domain subject a little bit, but I thought I'd cover. It's interesting stuff. A little bit is kind of bleeding edge, but go with the flow for a moment. So this happens to be my favorite asset on the face of the earth. It happens to be the Brooklyn Bridge. It was design started in 1870. It was completed in 1883 in May. So it took 13 years to build it, and it's still in operation, obviously. So it had a design and build cycle of 13 years, and then over 130 years of operate and maintain. It's a beautiful bridge. I like it because it's the only one with the wires that both go vertically and horizontally, radial from this tower. So it makes these beautiful lines that intersect. And my hobby is photography, so I took this picture and particularly like it. Now, the original purpose of the bridge was this promenade here, which used to extend quite wide. And the main purpose of the bridge was for people in Brooklyn to be able to walk to Manhattan for the manufacturing jobs at the time that were in Manhattan. Cost a penny to cross the bridge, which today is $1.35. So, it's kind of reasonable today's money. Now, underneath the promenade, there were 3 lanes in each direction. One for a cable car, another one for horse and buggy, and a third one for people just on horses. Now, I want to remind you that 1883 was before the car was invented. Invented by Benz in 1886. All right? And in the United States, cars initially were all custom. They started mass producing the cars in 1902 in Massachusetts, Springfield, and then the Model T came out in 1908. So the need for automobiles didn't occur until, easily 20 years after the bridge was completed. So, just by the way, the bridge chief engineer and construction manager in 1880s was a woman from 1870 to 1880. So the bridge was designed and was built. They were designed by men from Germany, but it was built by a woman. Just a side note there. So, if we look at this traditional way of looking at asset lifecycle management, to me this is obsolete. This is evil incarnate because it puts too much emphasis on design and build and not enough on operate and maintain. If this was applied to the Brooklyn Bridge, it would have been obsolete in 1910 and torn down. What really happens is we have this operate and maintain period where we decide that there are needs for changes, so the modification requests go in. Then there's this process of ranking them. Some go above the line, and then they become funded projects. So in the case of the Brooklyn Bridge, around 1900, there was a funded project to convert from gas to electricity. And then not too far after that, there were projects to convert the cable car lane, the horse and buggy lane, and the horse lane into lanes that could support automobiles. So as a result of this process, iterative process that occurs into the Brooklyn Bridge, we have today a beautiful bridge that's very, very functional and performing well for the city of New York. So this particular process better represents the actual business processes that are occurring in asset lifecycle management. So the purpose of this model, most of you in this audience will say that this model is intuitively obvious. And the real purpose of it is that those folks involved with asset lifecycle management can better communicate with those people who aren't. So if you're involved in asset lifecycle management and you want to communicate a problem to IT or to senior management that may have come from a sales background, for example, you can have a much more useful conversation with them. If the IT guy says he wants to integrate some applications that are completely nutsoid, you can have a more useful conversation with them by being able to explain the business processes that are associated with asset lifecycle management and get integration and business process optimization and business process automation that makes sense for this particular space. So this, in this slide I'm just throwing up here quickly to kind of reinforce the model. You see applications on the left that make sense for design and build, design authoring tools, project management, and then applications on the right that make sense for operate, maintain, things about managing maintenance, reliability, etc. Now, this now takes me into these three circles into asset lifecycle information management. And I just quickly think about the design of a plant and just specifying a valve. In the design and build process, they're very concerned about what's flowing through the pipes, flow rates, whether or not it's caustic, and they get to a model number. Now, on the operate and maintain side, they're much more interested in the bill of materials for that model number so that they can get the spare parts to repair and refurb that particular valve. So we have this vision that in handover, everything should be transferred over and operate and maintain. And I would suggest that we structure that a little bit different, that there's some information that needs to be preserved for the next project, like why you chose that particular valve. And there's other information that really needs to be handed over, like the model number. And then in operate and maintain, they need information like the bill of materials. And think about what needs to be preserved for the next project, because remember, this is iterative. There will be another project that'll need that information. Some information needs to be shared, a subset of that, and to fulfill this asset lifecycle information management process. I'm told that in the design and build, engineers on average spend 30% of their time looking for information. So if you could preserve the information from the previous project, you could have a dramatic improvement in the effectiveness and efficiency of the people who are designing the next project. Okay. Now I'm just going to go a few slides from some market research we did. This was a survey among end users. This particular one, we had 85 responses, and it's one that we did in partnership with Reliability.com. They helped us get some people to fill out help promote it, so we got some responses filled out. Most of the participants, 63% from operations rather than IT. The primary reason for this kind of solution has to do with the uptime, obtaining more uptime. That relates to the balance sheet and the P&L statement, specifically the P&L statement for uptime, where with higher uptime, you have more capacity that drives revenue, and it also, the removing of unanticipated downtime, unplanned downtime, really controls costs around material and labor. I would just want to point out that uptime affects the P&L statement. The next highest one was around asset longevity. The longer an asset lasts, you don't have to replace it. That conserves cash, which improves the balance sheet. The metrics of the senior executives are in the P&L statement and balance sheet. When you can affect those things in a positive way, you get management attention in a positive way, and you get budget, and you get the resources you need for your project to be successful. So the point there being that uptime, asset longevity are key metrics, If you're going to justify a project and you can relate it to those areas, you're much more likely to have a successful project and management approval. So this particular slide says, was one around what kind of problems did they have. And the point of the slide here is that quality problems are just pervasive around asset information. So there is a major problem about managing the information throughout the life cycle so you have accuracy. And, complete list, missing information, can't find it, out of date, are all examples about the quality problems with the, and I think, go ahead. The primary problem is associated with handover. Handover has to be probably the most dysfunctional process there is, and totally mucked up in most facilities. Here's the response. How do you do handover? Most of it is bulk transfer. That means that you have pallet loads of printed documentation that gets handed over to the operate and maintain, to the asset owner. Just horrible. Now, nowadays we get more modern about it. We put those things in PDFs on a server and we hand over a server. So instead of a truckload of printed, it's handing over a server. I suppose that's a little bit better because at least you can do search on it. But that bulk transfer is terrible. And very little around a well-defined business process. Of course, people could check off multiple items in this question, and then the second one, the ad hoc sharing among individuals, that basically means you're calling somebody up on the phone or sending an email and asking them to email a document back to you. And to me, that's even worse than bulk transfer, because how do you know whether or not it's current, whether or not it is accurate, whether or not it's the right one you need? It's just totally chaos, out of control. So in terms of how to fix it, one of the big issues is management of change, to keep those documents up to date and current, so not only can they be used for operate and maintain, but they also can be used for the next project. And our recommendation is to use a stage gate process as a way to do this, meaning that as there is a major increase in either work effort or resources that are needed during the design and build of a plant or a project, you bring in the operate and maintain people so they're involved in the approval of that stage of the process. And they become aware of the information that's available, and they pull the information more gradually as the project is completed, rather than waiting for the end and have a massive transfer. Great. Now for something a little different. Let me first go ahead and talk about PDM. I'm going to focus on the right-hand side first, that big box. This is some information that, quite frankly, has been around a while. UAL first did this kind of research back in '68, but it's been done in Europe by Broomberg, and then the U.S. Navy did a couple. The fourth one is starts with sub, is really focused on submarines. But you can see from the dates up there, this has been around. It finally sunk into my thick head what the true meaning of this data is. The top half are age-related failures, which are usually related with wear. It's kind of like changing the oil in your car. The oil wears out, and you need to change it. And that's where preventative maintenance makes a lot of sense, because you can kind of predict when the oil is not going to be good anymore, and you just proactively repair it. Turns out that 82% of the failures are random in nature. As we get more electronics and more complicated type of equipment, the randomness plays in there. So when you think about it, preventative maintenance really doesn't fit well where the likelihood of failure or the failure pattern is random in nature. So now that starts to bring me over to the left side of the slide, where it's more of a maturity model of how you maintain assets: reactive, preventative, predictive, and proactive. And the point of this slide is that your preventative maintenance only makes sense for, round numbers, 20% of your assets. Again, reminding us of what a great philosopher Pareto was. And the other 80% of your assets really need predictive condition monitoring type solutions. And the great thing about IoT, or industrial IoT, is it starts to bring down the cost of doing condition monitoring. So now you can start to afford to do it on more of your equipment. And that's happening both from a hardware viewpoint, adding intelligence to the equipment, doing the data collection, and also from a software viewpoint in terms of the cloud applications and the communications. So this particular slide is encouraging you to start to do more condition monitoring. And if, for the users out there, if you're buying equipment, really have a conversation before you buy equipment. Have a conversation with your OEM supplier about how they're going to help you do condition monitoring. All right? Sometimes they can offer it as a service, so you're not doing it yourself. What I want to talk about here is the workflow. Typically, each one of these areas is a little disconnected. The control system versus the EAM system versus the operator. And this slide is talking to the workflow automation, business process automation, so things don't get lost between condition monitoring and EAM, or it doesn't get lost between the EAM system and the maintenance technician. Those islands, typically an island is very well optimized within the island, but what goes on between the island is often dysfunctional. And this particular slide recommends some workflow automation. All the major EAM systems have a means to accept flags from a condition monitoring system. We're just suggesting that you use that capability. All right? And then for execution of the work order, have a mobile device for your technician, because now you're updating your EAM system in real time. You're collecting the data while the operator is doing the work, or while the technician is doing the work, so it's much more factual and much more accurate. Not only does your EAM system will, not only do you get better compliance from the technician, but your EAM system will be more functional. And now I'm getting out there a little bit on the bleeding edge. So this is maybe something to be a few years out, maybe a little fun. Vuzix has smart glasses, and they've got a business model that's actually successful around selling the smart glasses. People probably know that Google stopped their program and they're going to restart it. But there has been some suppliers who have been successful in that space. And I've been reading about this Microsoft HoloLens. Now, it isn't going to be out here until Q4 of this year, but based on what I was reading, that really starts to sound like a solution that'll fit how a technician could work, where you put the glasses on while you're working on a machine, and somebody, expert in that machine. So you could have a general purpose technician go to a very complicated machine. You can get assistance from the maker of that equipment, some technician who's very experienced in it in a totally different location, get assistance on how to repair that machine. I think this, in terms of executing work orders, there is some potential here. This may be where 3D, augmented reality gets some traction. So just summing up. Use the ALM model, the 3 circles, as a communication tool when you're talking to people who are not familiar with asset lifecycle management. I think you'll have much better conversations explaining to them the business processes of ALM. And use it to optimize your processes. Not only the processes within each one of those circles, but the the ones where there's a huge amount of waste, which is between the circles, in particular handover. For asset lifecycle information management and handover, highly recommend the stage gate process and layer on applications that provide governance. Who has control, who can edit, who can read, and who can update, and keeping track of where the most up-to-date documents are. And finally, recommendation is when you're sourcing equipment, really think about, really ask your supplier what their strategy is around IoT. And if they don't have one, really start thinking about another supplier, because this is going to become increasingly important for you to have higher uptime, much less unplanned downtime, and much higher reliability in terms of condition monitoring.